Good afternoon and welcome to this webinar. You will be muted during the webinar, but if you have any questions or comments, you can use the questions section at any time throughout the presentation. The webinar is recorded and we will send you a link to the video in a couple of days. Today we're going to talk about requirements engineering in the age of generative AI. Our presenter is Elias Josfi and I am Cecilia Karlsson. Let's start with a few words about the reuse company. What do we do? The reuse company offers a platform and a set of well-defined methods to support the implementation of an incremental and comprehensive reuse process. The approach is based on knowledge management and elicitation, quality assessment, interoperability across tool ecosystems, artificial intelligence, and smart search engines. Today's presenter is Elias Josfi. He is a senior consulting engineer at the reuse company. He has a master's degree from the University of Montreal and the IMT Atlantic School of Engineering. He has a background in energy and mechanical engineering and has been involved in different research projects. Elias is an active member of INCOSE. He has the ASAP certification and he is a major contributor to the requirements working group's INCOSE Guide to Writing Requirements. Elias is also passionate about international projects and languages. So let's start today's topic. Hello, Elias.
Hello everyone, and thank you, Cecilia, for the introduction, and thank you for all of you for joining this webinar. So before we jump into the topic, let's walk you through the agenda of today's webinar. So first, we will discuss the quality versus performance paradox in requirements engineering to address this topic of the rise of GenAI in requirements engineering, and also how to navigate through the many iterations of requirements engineering. So describing the requirements engineering process and see what kind of challenges could occur in those cases, and how to leverage what I'm calling the dual AI approach to navigate safely through these iterations and make sure that requirements get the highest quality possible in securing your decisions towards the design input and next phases of requirements of system engineering. Then we will see some use cases and a demo of this dual AI approach. And finally, we'll leave you some time for Q&A and a conclusion about the different topics. So first, let's get into this topic of what I call the quality versus performance paradox. So first, let's consider that this is something that everyone is acknowledging in all different sectors. We have a major investment in large language models, in generative AI, to help in daily activities in systems engineering, also in other departments. But if we focus on our topic today, which is requirements engineering, we have many organizations taking the step towards these kind of methodologies. So what we'll be seeing today is how this could help, but also what challenges we have. And one sure thing that we see when we apply generative AI in requirements engineering is that it appears as a performance booster. So it is speeding up requirements drafting and all the other steps towards the definition of the requirements for our system. So elicitation of requirements, requirements analysis. So we will see the different steps with more detail. But basically, what we observe is that it is doing things much faster than traditional techniques that we've been using and that we've been experiencing so far. The downside of GenAI and in these activities is that this accelerated production, so we'll see in which way it's accelerated, but basically this is more prone to volatility. So we generate more versions of objects. We process data in a fastest way, but we also generate more volatility and hallucinations, which is something that we face also using large language models, and this comes with a bigger quality gap. So we need to train the model to make sure that we reduce potential hallucinations. The quality of the prompt is very important. So something that is for requirements engineers, basically the characteristics of a good requirement could be more or less, if you transpose to the prompt, could be the quality of a good prompt. So you need to define completely your request. You need to be concise. You need to be non-ambiguous, not use any word that would lead to misinterpretation. So basically, as a requirements engineer, you wouldn't be too let's say too far from your comfort zone, but when defining a good prompt, it's something you need to learn. It's not something that you're trained with. So you need also to adapt to how to safely interact with large language models. And also you need to take into account the evolution of the models. So this also introduces volatility in your activities. So the model is growing, it's being trained, getting better, but at the same time, your activities are also feeling this change and will be impacted by this change. So if we summarize, let's say, what's happening now, traditional techniques, if we remain in a tool-assisted requirements engineering, and especially the review, which is where we mostly put the focus in automating such tasks, machine learning or deep learning, or in this case would be NLP-based algorithms, tend to have a higher quality. I'll get to the definition of quality and performance in the next slide, but basically they have higher quality because of the deterministic, the logic that is behind. So you apply algorithms, predefined standards, set of rules that will remain the same. So depending on a specific project dictionary, system context, so it's less prone to deviation of results and hallucinations. Whereas what would happen with an LLM would be that we get higher performance, so we get results in a quicker way. But what about the quality? So here I represented several examples to consider that not all models are the same. So your model could be more efficient in performance, but less having less quality, or reversed. We could have more performance, less quality, or more quality, less performance. You decide in which situation you might be facing yourself. So of course the learning curve is very steep, and models learn quickly. But basically the question that we would ask ourselves is how to overcome the requirements engineering paradox. So GenAI is introducing higher performance in terms of speed and volume processing, lower quality regarding what we call the objective evidence, so referring to the what the verification and validation tasks are supposed to produce, and the determinism that is lost due to potential hallucinations of the models. So models will be improving in that aspect, but so far they're still producing these hallucinations. And you also have the variability of the results depending on how good the prompt is. So if you have a good model but the prompt is not good, then you're not securing your results. So eventually you need to have this counterweight that would be represented by traditional methods. And in this case, if we talk about NLP, which has been what we've been working on and experiencing in the past decades, it's introducing higher quality, consistency in the results that you get from the analysis, from the assessment, deterministic logic, but rather lower performance when it comes to handling higher volumes of data. And also there's a higher initial overhead. So having this consistent, predefined context, predefined set of rules, requirement patterns that you would like to follow, it comes with an initial overhead. So basically what we would like to do is somehow leverage the high performance of LLM and have somehow the quality of these traditional techniques help the LLM. So what we are looking for is a relationship of synergy between these two ways of working. And if we go back to the quality and performance paradox, when it comes to quality, what we're looking for is reliability. So repeating identical tasks, so checking the quality of the requirements, analyzing the completeness of traceability. You could name your use cases, but eventually what we want from the model is to be reliable enough to give us results that don't depend on many inputs. And that's what we're looking for when it comes to quality, whereas the performance would be related to task processing, if I need more or less pre-configuration. So let's say, how well does it deliver the results? Usability. So more than how well, we could also say how fast we get the results. So we could have similar uh, properties here, but what makes it more having more performance is how fast I get the results. So that said, as I was mentioning, we need some synergy between requirements engineering processes, traditional processes, and AI. And we could see it in both ways. What we call AI for RE, which is applying AI algorithms to support requirements engineering processes. So as we will see in the next section about requirements engineering, there's a high load of iterations, and we have to live with that. These processes are iterative in nature, and we need to make sure that we have the ability to process changes in the fastest way. So AI would be supportive in that endeavor, and we would improve this requirements engineering chain. On the other side, we need this process-based activity, which is requirements engineering, to assist AI into being like fitting into this process. So AI being an enabler to requirements engineering and not replacing the whole process. So we have a process for a reason. So if we introduce AI as a giant black box that is supposed to deliver requirements, then we're not respecting the process as it is. So when in systems engineering dependent activities, then we need this process to be well defined. So performance brought from AI to support our RE, human-based, human-in-the-loop based processes, and quality on the other side to support AI into delivering better results. So if we look at a process or how we would represent it, so we have requirements management that is um, like governing the whole process, and we have requirements authoring that comes into play when we have to rewrite, rethink, reevaluate the inputs based on our errors that we found in the verification step of the requirements definition. But let's focus on this this chain here. So as said, it is iterative for many reasons, because the criteria to reach final verification, final validation might be hard to meet, or because we have errors, we have changes introduced based on a new need coming from the stakeholders, or change is coming from the context of the system or the organization, regulations, a new competitive, introducing a new technology that we need to take into account. So it could be different reasons, but we need to accept the fact that this will not be a single-sided chain that will be leading to the requirements in the first place. We'll need many iterations, and the real question is, how do we manage these iterations? And depending on using traditional processes or AI-based processes, or what we would be introducing, which is the dual AI approach, there's a whole new approach to it. So iterations, we have one here. So if the validation doesn't give these satisfactory results, then we need to go back to the elicitation, because that means there's a lack of understanding, or we're not covering the needs from the stakeholders. We have many iterations in the analysis here, because everything that comes from the previous steps would be needed here to be reevaluated, rewritten, let's say with the goal of closing the gaps, and also here in this process. So how should we tackle that? So iterative processes and activities, we have to accept that, and our verification and validation steps in the end serve as decision gates to trigger the iterations. So how do we decide to, why do we decide to go back here? One thing is the change that occurs, and we need to take that into account. If the change is introduced and this change is impacting the result of the verification and validation, then we would have to go back. And that's really where we need to be clear on the criteria. So as I said, giving the whole control, let's say, or the whole ownership to AI to do that would be not mastering these criteria. But eventually we need, since it's iterative, we need to automate somehow these activities to support the reviews. So how do we find the balance between too much AI and too few? So that's where we need to set the right balance. The goal of all these process, of course, is to define a correct, complete, consistent set of requirements, specifying the system functionality, characteristics, interfaces, and so on, that will fulfill the stakeholder needs, and make sure that we don't fall into the traps that are mostly identified here in this example of the chaos report. 30% of projects fail due to incorrect, inconsistent, or incomplete requirements. And that said, what we need to overcome this challenge is to define proper rules and standardized practices for requirement specification. So this standardized practice, this clear set of verification and validation criteria needs to be controlled, and we need to have a clear quantification of that. So I'll come to that later, but verification and validation talk about providing objective evidence. So how do I provide objective evidence if I don't have quantified and I have a secure control of the way we define the verification criteria for the requirements? So how do we check the requirements? What's the basis for that? And the more we have control on that, the better we would manage this requirements engineering chain. And so in order to get this, we have, of course, to train requirements engineers into having these set of requirements of high quality, and tools and methods to increase efficiency and support decision making. That this is where AI and requirements management tools, ALM, PLM tools, you name it, all this set of tools together would be helping in this process. So, but training requirements engineers is also important. If you have the best tools or the best methods, but you don't have the training, of course, that's not preventing from doing something wrong. So when it comes to applicability of AI agents into this process, we could check different levels of applicability. In the elicitation and analysis phase, we could consider that there's a high applicability of AI agents, mostly because we process large volumes of data and we could detect possible conflicts between the different stakeholders and also patterns if we find similar inputs that would be grouped, classified into different sets of needs that would then be converted into the requirements. So this way we can speed up the elicitation and then the analysis. So, and considering that changes might occur with a large number of elements, that would be much easier if done by LLMs, which are very good at analyzing natural language, which is where how we would define the stakeholder inputs. Mostly, we could have models as well, and models can also be processed by AI. But then we have this specification in the middle, so it's a moderate applicability. We need the human in the loop. Models could lack the deeper context of the system constraints, and we need to monitor the output uh, uh, by the systems engineers. So in order to make sure that this output is a good candidate to go through the verification, then we need to control the output. So we cannot like have all the process be monitored as a black box. We need to secure these intermediate outputs somehow. AI could help in that way as well, but it would be like a self-learning improvement. So we want to avoid too many iterations, and that's why it's not totally uh, uh, like autonomous, if we would say that. And so, and finally, the verification and validation would have a low applicability for the main reason that it has the need of objective evidence. So how would the objective evidence be demonstrated if we don't have a clear set of criteria, quantifiable, based on the standard? So, and that mostly concerns people who are following system engineering based standards, such as the ISO 15288 or the corresponding application in the different industries. So we need to define this verification and validation criteria. So not only the criteria, but also how we would check them, what's the weight of all the criteria. So we need to have some control on the way we check the requirements to make sure that if we rate the requirement, that's what we are pursuing as an objective. If we want to rate the requirements, how good the requirement is, we need objective criteria. If not, then it's like a qualitative feedback, and we're not sure that it's totally matching our needs here. So what is a good requirement? What is a poor requirement? We need to define that with objective evidence, and this is where the dual AI would come into play. So basically, what we would say is AI agents would be good inside this first three blocks of the requirements engineering chain. Here you would say it's kind of outsourcing your work to an external, not external as such, because the model is internal, but out of your core team of engineers, or the human team, let's say. So this is a tool. It should be considered like you're outsourcing this work. So when you outsource something, even though you trained the agent, you're outsourcing your work here. So you need to check what's happening here. So one way to support this quality check would be using the traditional techniques, and we'll get to that in the slides and and then in the use cases. So this dual AI approach would be, as I said, based on GenAI as a methodology to support the first phases here, and then we would have traditional NLP, natural language processing methods enabled by AI. So AI is used as let's say as an enabler, as the front end, you could call it as you wish, to trigger the actions, but the actions would be based on something that is reliable in terms of quality, and that way we would bring the best of both worlds within our process. So if we have like this evolution, so LLM is a like part of deep learning, and which is itself a part of machine learning. So why not embracing the best of all the options here instead of just limiting ourselves to what LLMs can do? So if we have different options, then we have to use the right tool and the right method for that. So that's what we are pursuing with this approach. And if we look in a systems engineering perspective, what we would call a enabler for the RE process. So we need to consider processing the input using AI to have more efficiency, maximizing the outputs to produce more data and get quicker in the iterations, so performance, and rely on traditional techniques to execute and monitor the activities. So this is the process from the system engineering handbook from INCOSE. So those who are INCOSE certified, they probably know this this diagram, or they already saw that diagram before. And basically, it's defining how we convert the inputs from the requirements definition process into a set of outputs. They could be in different layers. So inputs to the design and architecture definition. We have iterations to refine the needs that we have, and also the traceability. So and this is for all the processes. We have the enablers, and AI should be an enabler. It should not replace the whole activity for sure, and it's not like shadow, like like shadowing. You shouldn't be shadowing the activities performed here. So they're human-based activities. We have a review in the end, so we need to make sure we do analyze the requirements and manage the requirements with a little bit of human-based work. So if we were to sum up this like dual AI approach, in other words, we have what we call the old AI, which is based on NLP, securing deterministic algorithms, predefined, agreed standards for requirements quality. So we know exactly what characteristics we need for your requirements. Also, something that could be difficult to approach if you're using a full generative AI based process for requirements engineering is how do you adapt the criteria based on the level of criticality of the document, the level of abstraction. So how do you make this decision, and how do you make sure that this decision was taken based on objective input. So if you need to justify the criteria, then there's no other way to define like these deterministic approach, and using this what I call old AI. So they're both AI algorithms in both cases. So when the deep learning, machine learning, so machine learning, deep learning, and LLMs, they're all within the AI field. So, and in this case, what we want to do with this approach, securing deterministic algorithms and reinforcing consistency, is to reduce the number of iterations. While using LLM-based algorithms, we accelerate the content, and what we do is reduce the time necessary to perform an iteration. So if we don't use both aspects, of course, we might end up reducing the time for iterations. But if we have 20 iterations, then is it really worth relying only on this? And of course, if we remain in the old AI approach, out of resistance towards new algorithms, or to consider that, we might be we might feel not confident about the results from the LLMs, then we might have maybe less iterations, but each iteration would take more time. And since we know that we all have like high level standards constraints for and reducing the time to market is something that we're all facing in different industries. Then we need to make the most of both approaches here. So this joint effort to maximize the quality and efficiency of the processes. So an example of the verification criteria for the requirements would be to use the INCOSE guide to writing requirements. So we've been presenting so how we do that with our tool set. So with our SAS Engineering Studio solution. And so the guide to writing requirements, for those who are not familiar, is a guide describing 15 characteristics for well-formed requirements and sets of requirements. So needs and requirements both are being covered, and these characteristics are checked by the compliance to 42 rules. And these rules have been implemented in our toolset SAS Engineering Studio as 58 quality metrics. So this is how you would quantify your quality. So not based on qualitative descriptions, but based on real indicators that you would be using to secure your verification and validation for your requirements. So let's get into some use cases here. So when we think about the requirements engineering ecosystem here and how a tool like SAS Engineering Studio would apply, we have plenty of different use cases. So those in yellow are those that will be covered during this demo. So if you have any question about the others, so please reach out using the contact that will be shown at the end of the webinar, or just ask your question if you'd like to follow up later. But yeah, basically this is the whole ecosystem, but we'll focus on some of the use cases here, showing what's the current, like what we call the traditional approach to automating these processes, and also how we would involve LLMs into this this activity. So if we look at the first one, the quality assessment, so we could look into different use cases. So the first one would be how to check requirements quality in the tool using this what I call traditional approach. So the traditional approach is basically using NLP algorithms and a set of quality metrics. You would be able to check your quality. So you have some requirements in your ALM tool. In this case, I'm displaying an example with Polarian. So Polarian would be your source tool, but it could be any of the tools that main tools that you have in the market. So we have up to 50 connectors to be able to gather this requirements database. And considering your source of requirements, so your traditional methods could help you secure the rewriting of the requirements or the quality check. So in that case, we can access the quality check by configuring the quality metrics that will be used here. So you have your predefined metrics, ears, syntax, INCOSE, guide to writing requirements, metrics. And then based on these pre-selected set of requirements, then you could just access any of the requirements in your database. And so if you use the authoring tool that is embedded in your web browser, you would be able to rewrite the requirement following your guidelines. So that's, let's say, the what we would say the current, or like the old AI, as I was mentioning. So I'm going to show an example here. So you see you're using should, it's a band modal verb, you're using a passive voice, you're using a superfluous infinitive at the same time. So very basic example. And then if you want to use the ears syntax, then the tool is guiding you into the different slots of your sentence to be able to ensure you have the right syntax for your requirements. So either way, just by being guided by the metrics or including the syntax, the style guide in the process, you would get your requirements. So it's also can tell you that the value is not including the tolerance. So you have the issue here displayed, and what you would do is include your tolerance, or just consider this as a maximum value, and that would do it for this requirement. So that's for the authoring side. Then this set of requirements could be checked within the authoring tool, within the desktop application, the SAS Engineering Studio, sorry. And this set of requirements, basically you would assess the quality using these metrics that were predefined, and that would be where you would be able to get the results, export these reports to the writers so that they can improve their requirements quality, or even like write the attributes of the quality back to the source. So you can also save snapshots to see the evolution of your requirements quality. So you're monitoring your verification and make sure that each baseline is verified based on this requirements quality standard. So once we get the results here, you're refreshing the page, you get your requirements quality with the summary of the found errors, and that would be your way to deal with that. So that would be what we do with the what I would say the traditional method. So, but what about using LLMs to support us in that? So that would be one option. So here in this example, I'm using a web portal that is including the so I'm just going to wait for loading a little bit, that the image gets better. Yeah, but yeah, you have your document loaded. Yeah, now it's getting better. Okay, so you navigate through your documents. So those documents have been previously loaded in the synchronized hub that we have through the desktop application, and users using the web portal would be able to access the documents, the contents, the models, every source that is connectable. As I said, we have 50 connectors, would be connectable from the server, the desktop tool, and then you will be able to navigate through the different elements. So here you can flow down to the different levels. So imagine that you could use that as a traceability viewer as well. And if we look at one of the medium quality objects here, let's say, instead of using the authoring tool to type myself the rewritten option, what about if we use an AI assistant? So you see some of the features here, traceability, quality are available. You have the hierarchy that can be viewed here from the tool. And what about if you use our AI assistant to support us in rewriting? So we have some predefined actions. You could also type your request, and so like your prompt to get the quality info, or to get the suggestion to rewrite the requirements. And so the first loading is loading the context. So here is where we would have the support of our defined set of rules. And after we get this loaded, then the tool will be able to give you the rewritten option. So it's analyzing potential elements in the context that might be flagged errors here, that might be breaking the rules of INCOSE. And you have some options here that are, so the suggestion that is done here is to overcome the rules broken here, INCOSE rule 5, 4, 8. So unambiguity, correctness, conforming requirements. So you have the summary of everything that has been done, and the rationale of the changes that are to be applied. And then this change could be saved and populated to the source. But let's say that's one of the things I was saying about the dual approach. So I'm not happy with the result, because this is using the be capable of, which is not something that the shall be capable of is not something INCOSE is accepting. So if we want to, in another improvement, so we would ask the model to give us some improved elements. So we can go one step further and say, okay, you gave me this rewritten option. Let's see if you have other options here. So the model here is considering shall be operable, shall support. So using action verbs and not shall be capable of, which is not exactly what we need here. So you see how using different algorithms we can get the best of the of our rule set to improve the requirements. Okay, so if we consider other aspects of the approach, so we have requirements verification, requirements authoring, requirements rewriting. So we could consider other aspects like the requirements classification. So I could give you an example here of requirements classification. So if we get into the requirements classification use case, what we would have in this case is, if I go back here, what we would have in this case is how we could use AI to categorize the requirements. So that would be very, very interesting in screening the requirements that we have been generating from the elicitation and analysis phase. So how do we get our specification? How do we organize our requirement set so that we ease also the final review? So in our model, we could have different models connected. So this is the desktop application. We could also consult this classification from the web portal that I was just showing before. And if we ask the model to classify the requirement, then you saw the rewriting requirements in the portal. So that's the predefined button. So that's a predefined option. We would have the same in case we use a web portal. So classify my requirements is a predefined action that is triggering our response. So then we have all these suggestions, and these suggestions could be accepted. This is tagging the requirements with one classification category. So we define that's also part of the dual approach. We don't leave full control to AI to provide any classification category. We define previously what kind of classification we're expecting, because we probably have a standard or an attribute that is expecting values for these classifications. So we cannot have 30 categories because the model thinks we have 30 categories. We have to give this input upfront, and so that's part of the making the undeterministic behavior of LLMs more deterministic, and that's one possibility given to the model based on that algorithm. So then we can add this into one attribute, and the rationale for the classification could be added into one rationale. And as you saw in the use case map that I was showing in it as an introduction to this demo section, we can interoperate these attributes to other tools if you wish. So then this could be saved. It's maintained in the synchronized source of truth and also written back to the source tool. Okay, so we have other two use cases here. So all these links here will be clickable links that you will get in the presentation that will be sent a few days after the webinar. If we look at like I said, the notebooks and how the web navigation using LLM is offering an accelerated use case for you to navigate through your requirements. So let's look at this use case here. So I will just run this video. What we have in this case is different options offered by the web portal, such as visualizing the traceability, using notebooks to trigger mind maps, quality analysis, summaries. So you have different features offered here, and you always have your AI assistant ready to use. So you have here a set of requirements. These are synchronized from Doors project. It's a Doors module that you have available here. The word document is the let's say the common name for all the pieces of projects that you're opening in this viewer. And so you can view the different attributes. You can perform traceability, create traceability links, view the traceability, if it's an out link, an in link, if it's a derives, satisfies link. So you may have different features here to work with the traceability. And then we could also ask the model to provide a summary of the document. So that's one of the interactions that we would have. So something that traditional algorithms would not be as efficient in giving. So that's one aspect that we want to secure with that. So key sections, important requirements. So easing the process of reviewing, stressing on different sections to make sure that we speed up the process. So one aspect is using this approach. I'm not going to show the rewriting because we already saw that, but we can implement. Yeah, you can have this requirement rewritten, and then if we go to the notebooks here, we can have different notebooks created based on the sources that are available in our repository, our synchronized source of truth. So every tool you're working with would be remaining in your ecosystem. What we do is gathering them together to make sure that we can like analyze this consistent set of assets. So we can create mind maps here, navigate through the different elements, and then see the different objects that belong to these elements. So that's one kind of applications that the tool might have here, and we can ask about a specific topic here. So creating more content to make sure that we understand the intent behind the requirement, which is also easing the review. There is the classification that we can view from the viewer, from the web portal here. And if we look at overlapping requirements, for example, partial overlaps, 3 high overlaps. So for example, here, if we look closer into this example, at the end of each round, when the combat mode is finalized, shall request the total time within the defined thresholds, shall display on the screen the total time within the threshold. So high overlap here found by the model. In that case, it's also increasing performance when using LLMs, but we need to couple this with traditional algorithms to secure the syntax of the requirements and so on. So more examples here. So as I said, these videos will be shared after the webinar, so no worries. You can look at them a bit closer when the recording is displayed. And if we look at a summary of the use cases, so we checked the verification of the requirements quality using the traditional approach, predefined rules, creating the reports or writing the attributes back to your requirement source. We saw Polarian in an example, but it could be Doors, as we saw as well. We used Doors in some of the videos as well. Rewriting using dual AI, either using the requirements authoring tool in the first clip we saw, or the second one, using AI to suggest rewritten options, classification of requirements, and web navigation to generate summaries, and use the notebooks to analyze deeper overlapped requirements, doing mind maps and so on. So some takeaways here, before we jump into the Q&A, don't let generative AI become a technical debt generator. So we saw that it's could have hallucinations. My example with the rewritten requirement was an example showing that despite following the rules, we do have the be capable, shall be capable, which is not a valid example. So you need to make sure that you have a set of rules that support your verification. This quote is basically what summarizes the feeling of having this balance between traditional and human-based and generative AI-based algorithms. So you don't outsource everything, otherwise you're leaving the AI working for you, and that's not what you're expecting. You expect AI to be a copilot, not to be the pilot. And also by doing that, you eliminate the verification and validation ping pong between like different versions that need to be reviewed and who are not which are not following the criteria. Okay, so Cecilia, back to you. Do you have any questions?
Yes, thank you, Elias. Yes, we have some questions already, but please continue writing down your questions in the question section. Elias will answer in a minute, and I will just quickly tell you a little bit about our upcoming webinar. Our next webinar is about how to reuse systems engineering assets in complex tool ecosystems. In complex systems engineering environments, organizations rely on different tools, standards, and teams that are maybe located in different places. And as a result, many teams recreate existing assets, leading to increased costs, longer development cycles, and reduced efficiency. So what you will learn during this webinar is how to reduce non-recurring engineering effort, improve quality and consistency, build a scalable knowledge-centric engineering environment that supports digital engineering and model-based systems engineering at enterprise scale. And the date for this webinar is the 28th of May. Okay, so over to the questions. When overlaps are identified by the tool, but the user confirms that they need to be kept separate, is this confirmation recorded so that this overlap is not highlighted in a future analysis?
Okay, so let me try to rephrase to make sure I get the question right. So you get two overlapped requirements, and you want to make sure that if you decide rather to separate the requirements, or like overlap requirements could be that some of the statement of one requirement is included in the other, or that you simply have like just two similar requirements. So whenever you decide, like if it's a real overlap and you delete one of the requirements, or you decide to like supersede one of the requirement, or if it's included in the other one and you change the description, you would have a record of that, because the tool is synchronizing data from and to the source of truth. So if you decide to manage this overlapping within our SaaS Engineering Studio, then you would be able to get a record of that.
Okay.
So hope this answers the question.
Yeah, hopefully. If not, you're still in time to ask more questions. Does the quality assessment tool check that requirements are consistent with a product breakdown structure or function breakdown structure? Does it need to be pre-configured with the PBS or FBS, or does it extract it from the existing documentation?
Good point. So yeah, we do have this capability. So as you saw, we have these algorithms that can check the content. So not only the syntax, but in that case, the consistency with with external sources. So we can have the knowledge base connected to models to get FBS or PBS structures, and these could be used to make sure that in your statement you're doing the right thing. And then LLMs are bringing also the ability to extract this kind of information from natural language documents. So joining all these forces together, you would be able to check these structures against your document.
Okay, thank you. Do you have or are you aware of any papers that show the business results of improving requirements quality using generative AI? For instance, if I raise the quality by 1 grade level, I can achieve hard or soft savings or improve downstream performance or metrics.
That's interesting. So that's something that could be a follow-up discussion. So I would be glad to follow up about these topics. So if I find some literature that could be supporting that, of course, I would be glad to share. There are studies done with the current algorithms. So with NLP, we know that securing these processes while reviewing requirements usually divide by 3, 4 the time for reviews. But when it comes to GenAI, since it's pretty new, there are some studies done in the INCOSE requirements working group and the initiative. So yeah, if I have something that that is already available, of course I would be glad to share with you. But let's follow up to discuss about that.
Okay. Another question, is the AI check based primarily on INCOSE, on clarification or unambiguous rules, like the 12th or 48th or 52nd rules, or whatever the numbers were, meaning NLP check of clarity?
Okay, so basically, this is the main point of the approach here. So the example you saw with the requirements rewriting, what we want to achieve is that it checks against your set of rules. So it could be the all 58 metrics. It could be a narrowed down set of metrics if you decide to apply less. But that's the point of choosing your verification criteria. You can set up your metrics in the tool, and then the model would be using this particular set of metrics. Because when you select a source document in the web portal, as I was showing, this source document has been assigned one set of metrics. So the model knows which metrics it needs to use. So it's not a varying number of metrics that you don't control. Is exactly which metrics you would like to use. So it's a deterministic approach based on a predefined set of rules. So it's NLP based.
Okay, thank you. Does the AI integration allow for pattern-based authoring templates to which the AI can validate against?
Yes, so again, you could use both the NLP-based approach, which is pre-suggesting the different slots, and you can write along the way, but you could also have your AI assistant check this syntax, and it can tell you if it's matching or not. So one use case could be you get a document connected and you ask your AI assistant, could you tell me which of these requirements are following this pattern? And that would work also in this way. It would be kind of a style guide checking metric in that case. But yeah, you would be able to do that.
Okay. Does the requirement elicitation or authoring allow for contextual-based authoring of model element information?
Yeah, in that case, if you connect the models to the knowledge base, then the tool will be able to take this source into account. But very important, it's part of the traditional approach. You need to define your sources. So your sources of truth need to be connected so that you can do that. But eventually, once you do that, you can make sure that the context is loaded. But it's a preliminary step you need to take.
Okay, one last question. Is the AI-assisted requirements quality checker supported on the Rex Word add-in?
Good question. So so far, so this is a new set of capabilities that will be released next month. So we already have most of them available right now, but the official release would be next month. The AI assistant is part of the SaaS Engineering Studio, so we would be able to trigger that that quality check from the tool. About the Rex, it's still to be defined whether we would trigger it directly inside the interface or have the desktop tool used. So that's something that could be discussed. So if you are a Rex user, then we can have a follow-up discussion and see what would be the potential use case for this future implementation.
Okay, thank you very much, Elias. Let's finish with the questions here, and thank you very much for attending. If you want more information, don't hesitate to contact us. You can book a meeting with one of our consultants. You can also ask for our personalized requirements analysis service. Or if you want to try our tools, you can request a trial license. You can also visit our website, reusecompany.com, for more information, and our YouTube channel at The Reduce Company for videos about our tools. We hope to see you soon again. Thank you very much, and goodbye.
Thank you, everyone. Goodbye. Have a nice rest of the day or nice evening, depending on where you're located. Bye, everyone.